are you everybody? My name is Eric Chow. Today I would like to talk about the role to computer science majors at the University of California. The University of California has 10 campuses, and one of them is focused on graduate school, and 9 of them have the undergraduate computer science related majors. And today I would like to talk about how to start from your high school computer science education leading to the University of California. First, let's look at what are the CS-related majors. From the engineering perspective, the computer science-related majors including the core computer science, the computer science and engineering, the computer engineering, the electrical and computer engineering, and the electrical engineering and the computer science. These are different majors that are provided by the University of California in various campuses. But basically, there is a core computer science field, a computer engineering field, and a electrical engineering and computer science field, 3 major fields. And the core computer science field is related to the study of computer and computing science, how to make computing faster, more efficient, and more powerful. And the computer engineering is focused on how to build a computer from the hardware and software aspects. And the electrical and computer engineering is focused on how the electrical signal can be used to provide computing purpose and solve real-world problems by using the electrical engineering techniques and solutions. From the science and management aspects, computer science has the following different majors. From the more business side, we have the Management Information System major, or called MIS major. Sometimes it is also called Business Information System or Business Information Management major. And then we have data science, and data science actually is based on statistics. And there is bioinformatics or business informatics department. And there might be also the software engineering, computer game science, and the core computer science. Computer game science is using the core knowledge to apply to the game industry. And software engineering is the development of the software in the software product life cycles. And these different data science or MIS system fields are using the computer science knowledge into the different data fields or business management fields. And recently, artificial intelligence becomes so famous, and it is related to computational cognitive linguistics, language computation, and the cognitive science. Basically, natural language processing and many different fields are related to artificial intelligence as well. Here is an example of the program that offered by the University of California at Irvine. It provides 8 different majors, including BIM, computer game science, computer science and engineering, data science, informatics, information and computer science, software engineering, 8 different majors. And these different majors has different curriculum. And computer science is the most flexible program, and it has the most enrollment in the UC Irvine. And it actually only has the required course primarily in the freshman and sophomore year. And these different other majors, after the sophomore year, they will be focused on different fields. And the core computer science field has 11 specialized fields. And other than these different 8 majors, they also offer 6 different minors. So my personal recommendation is to take the core computer science major and then pick another minor fields. That would be a good idea to make your curriculum to be more flexible, but also be able to specialize on certain domain fields. The computer science is the mixture of the mathematics and electrical engineering. And this is actually the view of the computer science for 30 years ago. But nowadays, computer science role is totally different from the intersection of the mathematics and electrical engineering. Nowadays, the computer science would need to have the core computer science knowledge and also the domain knowledge. So the view for computer science is completely different now. You have core math, and then computer science is using the mathematical model to solve the problem in different application domains. So computer science become more and more important, and it has the influence on more and more fields. So it is no longer focused on serving the electrical engineering. It can be used for mechanical engineering, civil engineering, generic engineering, science, digital media, game, automation, cyber security, operation research, management science, finance, statistics, bioinformatics, biomedical engineering, and electronics. So many different fields. So to study computer science, you not only need to have the core computer science knowledge, but also need to have a domain knowledge in some of these fields. And besides that, you also need to have good mathematical background. And the study of computer science, including the hardware side, the new computational substrates. You have the new architecture for computing machines. You have the confidence computing for security, networking, distributed agents. You have the GUI, human-computer interface, sensor industry, intelligent interface. You also have different modeling complex phenomenon. Actually, this is related to mechanical engineering, civil engineering, aero engineering, finance, mechanical, biological. So this is actually the domain knowledge. And computer science is used to study all of these different fields. So actually, you need to pick a specialized field and also get enough core computer science knowledge. Here are different subjects that you can study in college for computer science. But the problem right now is not all schools meet your computer science educational needs. So you need to find a college that best fits your own goals. So how can you pick it? Here are the sample study plan for the electrical engineering and the computer science sample program for a student that do not have prior college level math. That means you still need to take the calculus 1 and 2 in your freshman year. So here, this is the sample study plan for UC Berkeley's EECS program. And on the right hand side is the UC Berkeley's study plan for the computer science major in Data and Science College. So let's look at it. So the EECS program starts with Computer Science 61, that's Python, Computer Science 61B, that's Java, and then it followed by Math 53, and then you have the CS61C that actually is C++ and assembly language. So basically, in freshman year and sophomore year, you have 3 semesters of the Python, Java, C++, and assembly. And similarly, in Data and Science College, the computer science major also need to take 61A, 61B, and 61C. And there is also a prerequisite of Computer Science 10, but actually this might be waived by your AP Computer Science credit. And also, if you haven't got your AP Calculus passed, you might need to take Calculus 1A and 1B. And you also need to have Computer Science 70, the discrete math, to pass. And CT1A, CT1B, and 70 are used to claim majors in the College of Letters and Science. And as you can see, the first 2 years, they only focus on 3 languages. Other than that, you have very few computer science related programs. And in EECS, you also need to take Physics 7A and 7B. And after that, your junior year and senior year, you have approximately 16 different subjects to pick for the computer science. So actually, the real study of computer science has only 2 years. Similarly for the CS major in Letters and Science College. And also, both of them will require quite many general education subjects. And right here is the computer science curriculum for BS program in UCLA. Because it is a quarter-based system, so you will start from Computer Science 1, Computer Science 31, that's C, C++, and then you follow by 32 and 33. So basically, you have 1 year of the training in C++ and assembly. And the math, you also need to pass the Calculus 1, Calculus 2, and also Calculus 3, the calculus of multivariables. And after that, you go into the software development, and you also need to take some electrical engineering course. So actually, UCLA's program is more focused on C++ and the hardware side. And after that, you go into some algorithm study, programming language, probability, and the formal language and automata theory, and software engineering. So the required course by the UCLA computer science program is very theoretical. And you only have a few elective classes. In comparison, here is the program for the University of California at Irvine. You have ICS 31, 32, 33. These 3 courses are Python 1, 2, 3. And then you need to take Math 2A, that's Calculus 1, and Math 2B, that's Calculus 2. And then INF 43, that is Software Engineering. And then you start to take the first discrete math course. It's called Boolean Logic and Algebra. And also you have the discrete math over here. And then it followed by the linear system. And also you can take the differential equation or multivariable calculus for Math 2D or 3A for the linear system. And then second year, you start with 45C, that's C++, and then you have 46, that's data structure, also using C++, and you also have the 53, that is system software development, that covers several system level programming, touch the topic in operation system and concurrent programming. And there is also a class called ICS 51, that's on assembly and the computer organization. This course is similar to the UCLA's program on this introduction to computer organization. And then it followed by 67. So basically, the program in UC Irvine has 1 year of top training in Python and another year in C++. And after that, you have the algorithm course, and then mostly other computer science electives. So basically, you need to pick the right program for yourself. This is the chart I set up for the core course that required for the computer science majors. So basically, you need to learn some Python language for example, like Java 1, 2, and then be able to handle the data structure. To be successful in college, you need to have Python background, Java background, and C++ background. All of them need to reach at least the 2 level, the object-oriented programming level. And then you take the data structure course, algorithm course, programming language course, and then move up to compiler design. But compiler design is optional. And for the hardware side, you need to study assembly, computer organization, and computer architecture and microprocessor. These are optional. And maybe you can also take digital electronics, but this is for computer engineering or computer science and engineering. For the math part, at least you need to take calculus 1 and 2, but you may also try multivariable or differential equation. For the theory side, you need to take logic design or Boolean algebra, finite state machine, automata, and the computational theory, but automata and computational theory are optional. And additional math, you need to have Boolean algebra, discrete math, linear algebra. These 3 courses are required. And then for the software side, you need to know Unix scripting, operation system, and Unix or Linux lab. But this one again is optional for computer engineering. But this gives you the chart of what are the core courses that is required if you want to focus on CS major, but your school may not offer so many courses, or your school may not give you enough time to take so many courses. But to be a successful computer scientist, you need to have these different backgrounds. At least all pass the 2nd level right here in the middle. That's a minimum requirement for a computer science major. And if you want to use computer science, specialize in network programming, you need to know distributed programming or concurrent programming. You need to know client-server programming, database, and graphic user interface. And these are many different things. You may take the courses in school, or you can actually study on yourself or take some online courses. But at least you need to know about database, data science, and some of the GUI package, and also client-server model, and some concurrent programming knowledge. For computer science specialized field in artificial intelligence, you actually need to take all of the algorithm courses, programming language courses, and then you need to have some language, for example, like Python or R language in good proficiency, and then also need to know how to use those packages well. Besides that, you need to know about linear system and also the statistics or some more advanced data science or data analytics courses. And then from the engineering side, you may need to take engineering math or signal and system or even stochastic process or random process. But the overall goal of the artificial intelligence is optimization theory, so you need to know about the optimization theory and also machine learning knowledge. And to organize your course, basically at least you need to go through the middle part, go all the way up to the artificial intelligence and some machine learning model, and then the optimization theory. The optimization theory, I believe, is a core course for artificial intelligence, and also you need to learn machine learning model, and statistics is also key. So these are the core courses for artificial intelligence. And the bottom line is math is the key. Math drives everything, and computer science is making things happen by using applied math or mathematical model. And for students transition from high school to UC computer science major, you should look at your mathematical background, Algebra 1, geometry, Algebra 2, and the trigonometry, pre-calculus, and then calculus. These are the typical mathematical pathway. But remember, there are a few different topics that are also very important, including probability, statistics, set theory and logic, number theory, and also more advanced analytical geometry, sequence and series, and limit theory. And these are important courses. So, here is an example of how you can prepare your own student to move up to be college ready. In order to get admitted to UC, I believe at least you need to finish your high school up to here. And to be more competitive, you need to move up your student up to here. And to be AP Computer Science A ready, I suggest your math need to be here before you can take serious programming course. Or some students, if they are good or hands-on student, the minimum requirement for AP Computer Science student is over here. So this chart gives you the different math level or the standard test level. How can you prepare your student for different level? For example, if you want to take general SAT math, at least you need to have your student pass Algebra 1 and Geometry. And then if you want to take SAT Subject Math 1, you need to have Algebra 2. And if you want to take Subject Math 2, you need to pass Pre-Calculus. For AP Stats, also right here, that's the minimal requirement. And for AP Physics 1 and 2, at least you need to have your student pass the Pre-Calculus and Analytical Geometry. And for more advanced AP Physics, C, Mechanics, the Electricity, and the Mathematics, you need to have at least some calculus background. And some more advanced students may take multivariable calculus course in community college or discrete math in community college. So here is the curriculum for preparing your student to be UC Computer Science major ready in high school. And actually, if possible, try to have your student finish high school with this minimum of a AP Calculus course to make him more competitive in the college application. And minimum, you need to finish up to here to be considered for UC Computer Science major. So here I picked the Fremont Unified Secondary School for its math pathway. So as you can see, I put the boxes over here. And then from 6th grade, the normal path is the yellow one. And the red path is the accelerated path. So the normal student will finish pre-calculus at the senior year. But that's too slow if you want to be competitive for UC Computer Science major. So, the more competitive curriculum to make a student UC Computer Science major ready is at least this path. You need to have the pre-calculus in the junior year and the AP calculus in senior year. Or you can pick this path. That is more accelerated path, but actually this requires some test. And that one actually prepare your student more ready for the UC Computer Science major, but in fact, the math need to be handled well by the student. How secondary school students should proceed in computer science. Right here, I have my own slides showing you how to prepare a high school student in computer science. If you want to go to UC Computer Science bound student, at least you need to take some Java programming background, and after that, take AP Computer Science A course or exam. That's the minimum for UC Computer Science major bound student. If you don't have this, you may be admitted by the UC school, but you will have tough time surviving there. But if you want to be more competitive, at least you can move up to here. So basically, you need to pass AP Computer Science A and B for 1 year, college Java 1 and 2, and then you have some GUI background. And if you want to make your student to be very competitive in UC, you better have all of these 3 languages done in high school age. For students those going to UC but not CS bound, you can take basic Python and APCS principle. And before the series programming program, students also recommended to at least know some JavaScript, HTML, and digital imaging and video creation knowledge. And for the advanced student, you can also take data structure in the high school days. How can I get in? First, you need to have reality check by the inspection result from San Jose State University. For all Cal State universities, they use the eligibility index, that's GPA, that's Cal State Capit weighted GPA. So maximum 8 honor points. So the maximum GPA that can be reached is about 4.35 or 36. And that GPA times 800 plus SAT score, and the SAT is out of 1600. So basically you can think about the formula of 800 times GPA plus SAT. And how high can you be considered for San Jose State University? For the year 2018, the class of 2018 for computer science is 4725. And for computer engineering, not much less. But as you can see, these two majors are way higher than other majors. So computer science is very, very competitive. And the reason why I picked San Jose State is because this school releases this inspection result every year. And using that, we can know about the trend for how the Cal State school picks students. And San Jose State is also very competitive for application. So we know that if you can make San Jose State, then you may be eligible for UCs. So basically, in order to pass that, here if we use the 4730, that's a 5 point above the cutoff range, then at least your GPA need to be 4.1 and SAT 1450. So that's pretty high. And most schools using the GPA and SAT two-dimension chart to pick students, and this actually decides the 80% of the application scores. So basically, here is the key. At least you need to prepare all of the test score and GPA to be considered. And beyond that, you need to do enough of your preparation for HR curriculum or your AP courses. And that's the reality check. So right here, I finished my discussion for how to get into UC's computer science program. If you have any question, please contact me, and I would like to discuss whatever I know about how to get into the UC program in computer science, and also how to get your student ready and be competitive in the University of California major in computer science. Thank you. Bye now.